Hello all! In the previous video about this computer, we fixed the power supply replacing the power regulators, checked that all voltage were okay, and replaced some resistors that were damaged on the main board, as well as some logic gate ICs. Still, the computer didn't work. While it seems that it got an RF signal output, it was just completely blank. Today, in this video, we're going to explore it further and with an oscilloscope check the signals from the chips, from the CPU, from the video processor, memories, etc. Now, let's start. Now, I didn't close it completely after the last repair, just in case something failed, so there's less to take apart. So that was easy. Now let's plug it in, and because I'm going to plug it to live power, I'm not going to use the anti-static strip because I could get a shock from it. The first thing I'm going to check is some voltages to ensure that everything is being propagated properly from the power supply to the different components. So on the Silo C80 we have pin 11, that should be 5 volts. And yes, it is 5 volts. Now on the video processor, with this we have difficulties accessing it, so I'm just going to remove it before checking further. I have powered it off, obviously. Now let's try the video processor. that should have voltage on pin 33. I cannot find the voltage here. Yeah, I'm trying, but doesn't seem to have voltage on pin 33 as the datasheet suggested. Maybe I have the ground pin out. Let's check some of the RAM chips. So the RAM chips should have the voltage on pin 9. So here. Oh, that's strange. There's no voltage there. Maybe I'm not getting proper contact here with ground. Now I'm getting voltage. So let's try again with the video chip. Now with the video chip, I need to find a better ground point, because this one is failing for me. So here we have ground here on this one. I cannot put it inside. I'm trying to think about a better place to find ground. Maybe this here. Let's see if this gives us ground. Yeah, it does. Still not finding the voltage from this chip. Let's try another RAM chip here. And should be pin 9, 5 volts, 5 volts. And on the ROM chip it should be pin 28. Well, this is strange. I'm getting 2.8 volts. I'm pretty sure this should not be 2.8 volts. And here's 5 volts. Okay, this is the proper pin then. So maybe here I continue on reverse, and yeah, should be 40 then, 35, and then 33 here. Okay, yeah, 5 volts. I was sorry, with the dyslexia, counterclockwise and clockwise, I just fail on that. So yeah, okay, proper voltage on the video RAM chips, on the main RAM chips, on the ROM chip, the processor, and the video processor. So all the voltage seems to arrive properly to our places. Now let's see with the oscilloscope. Now I'm going to pick a cable so I can get the ground out from here from the connector and have it all times plug it to the oscilloscope probe. That will make things much easier. This DuPont cable should suffice. Let's check with the multimeter that I got the proper ground plane. So if I get this here and hold it to this DuPont cable and then try pin 9, I'm getting 5 volts, so it's propagating the ground properly. I'm going to hold it here and I have my ground reference point. Now let's see the signals from the chips themselves. So on the C80 the pins 1 to 5 are address, so they should change. And we can see on the oscilloscope that there's change, there is execution. Let me put auto setup so we can see it better. Yeah, that's correct. Now I'm going to check on the clock, but it's probably going to be correct. So clock is pin 6, 5 and 6. And yeah, there's a clock there. Says it has 280 nanoseconds of frequency, so about 3.56 megahertz. So yeah, right, completely. Now let's check pin 22. That should be white, or pin 21, that's red. Yeah, we can see it's going up and down. Certainly, yeah, it's reading and writing data. Now let's check the RAM chips. So on both of them, for the video chips, that 4464, and for the main memory chips, that 81416 or 8164. So this is different manufacturer of chip than I was expecting, but there's compatible, it's 4464 compatible. So they have the same pinout. So on pin 4 they get the write line, on pin 16 they get the cast line, on pin 5 they get the RAS line. So just I'm going to check any of that. Seems that the RAS line is always up. This doesn't look particularly good. Let's check another here. Looks the same. now for this chip that should have the same timings, it looks completely different. Now this is how it should look. So there are changes, meaning that the RAM is being refreshed, but since that the video RAM is not being refreshed, maybe it's just not working or it's not refreshing, not receiving the refresh signals from the controller. Let's check on the video one. So pins 37, 39 and 40 should be different clocks, so let's check pin 40 here. Properly clocked here. Another clock on 39. And another clock on 37, even is out of scale right now. Now on 38, 36 and 35 there should be the color information. So 58. Let's check up the scale. It's certainly something there that's very fast. It looks like some bursts. Let's check one of the colors. Yeah, there's randomly some color there. And we check another one here. It seems to be out of scale, but I can see the color appearing and disappearing. So it seems that the video chip is properly generating colors and has proper clock, and since the main memory chips has proper clocks, but the video RAM chips, I'm confused why it doesn't show a proper clock. So let's check here. This is pin 5, pin 10, pin 15 and pin 16. This will be the cache pin. Seems that I'm getting cache here. I wasn't getting RAS on pin 5. Let me check again pin 5. 1, 2, 3, 4, 5. Now I'm getting it on pin 5. Here. And here as well it was very phantom, but I saw it. So yeah, it's getting refreshed. Both of the memories are getting refreshed. The video processor is executing. The main processor is executing, so the only thing left to check is the ROM processor. Sorry, the ROM chip, not ROM processor. There's no such thing. So chip 20 it should be chip select and chip 2 to 9 address, and then 15 to 10 data. So just pin 2 here. That's a very strange looking signal. Pin 5 looks like noise. Or isn't that pin 5? Yeah, it should be. Pin 20 is the chip enable, so when it's time to read from ROM, it should enable. Same looking as the address signals. So everything looks correct. The ROM chip is not showing the same kind of thing what we are expecting, like for example from the main processor. The only thing that's left to check is the solder the RAM chips and test them, or test with a replacement, and also do the same with the ROM chip. So I still don't have the equipment to test the RAM chips, but I do have the equipment to dump the ROM chip, and it's known that sometimes on this computer, these ROM chips, the ROM chips become corrupted. So what I'm going to do is I'm going to desolder the 4 RAM chips and the ROM chip. I'm going to put sockets on their places, and then I'm going to check the ROM chip, dump it, and compare with a good dump to see if it's the problem or not. Then I will see if I have replacements, just to try with replacements for the RAM chips. I think I may have for one of them, but not for the other. So I will try whatever I have. And if it still doesn't work, I will write on an EEPROM chip a copy of the ROM and then try again. I'm suspecting, because the C-Log chip, the processor is executing, and there's video also, that is just corrupting the program. So whatever is on the ROM chip is corrupted, or the RAM chip is working but is getting corrupted. These are right now my suspicions. Okay, now I'm going to dump the ROM chip and see if its contents, via a hash or a checksum, matches the known contents expected on this machine. I'm going to open the software for the ROM programmer, so detected, and the chip itself is an N38256. So I'm going here to select a compatible EEPROM, that will be 27256. Here the AM doesn't matter really. On DIP28, I'm going to select it. Now I'm going to disable the check ID because it doesn't have check ID at all. I'm going to insert it as indicated here on the red one. Let's put it into the sieve. And close the sieve. Now let's read it. Continue with the pins, and it's read here. You can see that it has data here. So I'm going to save this as a file on the desktop. I'm going to disable pin detect so it doesn't ask me again. I'm going to read it again and see if I get the same data back. It looks similar. So I'm going to save it as another file. And now that it has been saved, I'm going to check the hash. Here is one, and here is the other. So let me check the hash here. So this is the hash I'm getting. I'm going to compare it with the known dump from MAME. So here the known dump from MAME says it's E998, so it's not the same. I'm going to check the second dump here. And now I'm getting different one completely. So if we check both files, we see that they are completely different. They are not the same. So whatever is reading, we can see here some text. That's okay. But whatever is reading is not reading it always the same. So let's just save a third copy. Copy 2. And check it again, the hash here. And yet another hash, so it's not reading it. This means that this chip is flaky, is possibly damaged. Some parts of it are not working properly. So now what I'm going to do is I'm going to download the MAME version, and I'm going to flash it on an EEPROM chip that we're going to test later on the computer. Now I already have here downloaded the version. It's the 8020/20 version, but it's supposedly the same as the /40 as I have from MAME. And now if I compare it, well, we can see here that the hash is not the same in any of them. And now if I get here, I'm going to load the proper dump. So yes, normal, everything okay. And it looks practically the same in every sense. It may also be that there are different versions, but the problem is that every time we're reading it's just giving different values, so it's absolutely not the same. I'm going to click verify, so it compares with what's on the chip, and it's starting to telling me that there are clearly differences. So there are 2,902 differences. So seems here on this first block of bytes that this is the jump table, so it's completely wrong. Now if we go further, we see that there are not here another difference. This is the same, and here another difference. This doesn't seem to make much. I mean, these are numbers and so on, so well. So if we look here, we can see that it's on 1000 hexadecimal. And if we look at the previous difference, we see it starts on 800, and now the previous one is on 0. So I find it curious that it's aligned. So it's every 800 on hexadecimal. See, 1800. So the differences are exactly at the same alignment, and this makes me suppose there's a problem with the chip itself, because this very precise difference of the alignment is always a couple of bytes, like 50 hexadecimal bytes. So yeah, here is going to be on 2800 hexadecimal, not on 3000 hexadecimal. See, it repeats consistently, so it tends to show that it's damaged cells on the original ROM, and this will clearly be the problem. So now I'm going to take out the ROM chip. I'm going to put an already blank programmable chip. This one I have is the AM27C256. So I'm going to this time select it exactly. So AM27C256. Again, the deep version. I'm going to load the proper ROM, and now I'm going to program it. Now it's telling me how to put the chip, so I'm going to put the blank EPROM chip inside. Since it has one pin that's not perfectly aligned, and I may need a little bit of help. Okay, now I'm going to program it. Now it detects the ID because this is the proper programmable chip. And now it's verifying and it succeeded. So if I click verify again, I'm getting the same verify another time because yes, I'm paranoid. And 3 times we have read the same data, while on the other one we just read different data every time. So now that I have this chip programmed, I'm going to get it out. I'm going to put the original ROM again, just for why not. If I click verify, you will see, sorry, I have to disable check ID and PID. So I'm going to click verify, and now it has verified properly. So now the chip has been read properly. Well, the other times it has not. This is interesting. So it seems that now the chip has started to work more proper. In any case, I will try putting the just programmed chip and the ROM chip and see which one works, because the problem may be that this is a programmer, it's not designed to read mass ROMs, so sometimes it can give some problems, but not usually. So I'm just going to check it and see if there's any change. I don't think it should be a change if I here select the NMOS version of the chip. So yeah. No, it's just house gone crazy now. Okay, let's see, verify. So yeah, now I get a lot of different values. So it's just this chip is not behaving properly. Okay, I'm going to load again the just doing verifications, because I'm this kind of want to try and try and try. So we have the proper MAME dump loaded. I'm going to verify with the ROM chip, the mass ROM chip. And now it succeeded. Just a second ago it didn't. I'm going to change it to the NMOS version of the chip. Load the proper one again. Yes, disable checking ID and PID detection and verify. And it succeeded. So we have the check now that the chip is not behaving properly. I tried and sometimes it looked like worse. So this is why I like to do this paranoia thing and try. Because some chips, when you start using them, they don't work properly. And then they got warm and they start working. Because the problem that they have is that transistor that's made of a semiconductor metal that's like not making proper contact, and when it gets warm, that metal expands and not starts making proper contact, and it works. Then it cools down and stops working. So that's why I want to try and try, let it cool and so on, and just be sure that it's working. And this one is not working after several times that it just didn't. So strange. But for sure I have written a version on EEPROM, and then I will check if the machine works with the EEPROM and with the ROM chip. And if it doesn't, then for sure it's one of the RAM chips I extracted. Okay, so after testing with the programmed EEPROM with the non-good BIOS version, it still does exactly the same. There is no video output, all the signals look exactly the same on the oscilloscope. So until I get replacement parts for the memory chips, both video and main memory, or the diagnostic tool to check the existing chips, I cannot continue. So that makes it all for this video, and I hope you like it for now. And we'll see if the next part of the video we finally repair this MSX computer. I'm hopeful of that because it's not very complex and everything points to the video or the work RAM or the ROM, but the ROM is already tested. So see you in the next video, and if you like this video and want to see more like this, please don't forget to hit subscribe. Also, if you want to support me on my goal of creating open source software for the preservation of computing media and computing history, don't forget to go to my Patreon. Any help that you give there is welcome. See you in the next video. Bye.